All right, let's get started. Can everyone hear me?
Yes.
Good. Yes, perfect.
Yes.
All right. So before we start, I already have a question from Aisatu. I'm not sure I'm pronouncing your name correctly. Who says, are there any suggestion you can give us for studying for the second midterm? So the first thing I would do to prepare for that midterm is really to go over all the problem sets and to do them at least twice, okay, to be sure that you are comfortable with them. And then in the second step, you may want to do some extra practice. And in that case, you can just let me know and I can send some extra practice question. Okay. So for instance, I can tell you work on that problem in that book chapter. Okay, in some problem set, I've put recommended problems that are in the books. That's also problems that you may want to try. But I would say the first step will be really to go over the problem set and to be sure that you are comfortable with them. Okay. Does it answer your question? All right. So another question, can you give more specification about the optional final? Okay. So the optional final is an exam for those who are not happy with your course grade. Okay, I'm going to compute your course grade based on the grade you have on homeworks and on the grade you got on the 2 midterms. So I'm going to compute that and I will give you a temporary letter grade that would be your course grade. If you are not happy with that grade, you can take this optional final and the grade you would get at this optional final would replace the 2 midterm grade. Okay. So initially in the syllabus, I wrote that the grade you get for the optional final would substitute to the 2 midterm grades, whether it would be higher or lower. But now what I will do, I will just take the maximum of both grades. So the maximum between the optional final and the maximum between the 2 midterm grades. Okay. All right. So the optional final is cumulative, which means that you will need to review all the material from the beginning. And I also expect it to be a little bit more difficult. Okay, it will be a little bit more challenging than the midterms. How many questions? So I don't know yet.
Do we have a choice of taking it either way? So for example, let's say we do the midterms and then we're not happy with the grade and then we might take the finals. But let's say, however, you take the finals, but you got lower grade in the finals or higher grade in the finals. How are you gonna do that then?
I'll just take the best grade between both. Okay, I'm going to compute the average of the 2 midterms, and I'm going to compare this average to the grade you get at the optional final. Okay, and I'm simply keeping the highest of the 2. Okay.
Professor.
Yep.
For obviously the class, it's pass fail, like a credit, no credit options. But do you know how it affects? Let's say my major is like this class is required for me because I'm an economics major. Do you know how it would? Since this is a major, do I still have the option to make it a pass fail class?
I have to check that. So I believe that, okay, it's a pass-fail, but say you get an A in that class, it would still appear as an A. Am I wrong?
No, it will act like no credit or no credit.
Say again?
It will act like a credit or no credit.
It's only credit or no credit?
No. You could choose to credit, no credit it, and if you don't choose, then you get the actual letter grade.
Okay.
Can I add something? So there is similar requirement for my finance major, and I asked this question about my finance class, and I was told that even if I take pass, but there is like a certain GPA that needs to be maintained with within like 4 or 3 courses, like it's still fine. Like even though it's my major class, I was told that it's still okay if I take it as a credit grade.
Okay, thank you so much. Thank you.
No problem.
Great. All right. Okay, is there other question? Any issue?
I also have a question. So will starting for the from the problem set will be also helpful for the optional final, or it will not be really helpful?
Yes, for the optional final, you just review all the problem set, and you might want also to do some problem from the book.
Okay. Thank you.
It's going to be a little bit more challenging, but it will still be very similar to what we have done. Okay.
Thank you.
Right. No more question. Okay. All right. So chapter 12. So the plan for today is to cover a subsample of the oligopoly chapter. Okay. So the chapter on oligopolies is super dense. And for me, it was very difficult to see what I would cover because I typically cover all the models in that chapter in one semester at NYU. So I found a little bit crazy that they put so many information in only one chapter. So I have picked up what are the essential models of oligopolies. Okay, so today we are going to focus on what is the most important in that chapter. Okay, so just to review, to give a little bit background here. So what are oligopolies? So far we have studied perfect competition, which are market situation in which you have many firms. Okay, so that's one extreme. And we have also studied monopolies. So that's the other extreme. You have only one firm in the market. So oligopolies basically is any market situation that lie between perfect competition and monopolies. Okay, so in oligopolies, you have a market with few firms, okay, but more than one firm. And here we are going to focus on the case where you have 2 firms. And when you have 2 firms, we call that a duopoly. Okay. So in general, all the results we're going to get here are can be generalized to market with many firms, with more than 2 firms. But for simplicity, we are just going to study the case with 2 firms. So second point, with oligopolies, product may be differentiated or not. Okay, so here I choose to stick with the simplest case in which products are homogeneous. Okay, so we are dealing with the same product. The 2 firms on the market are supplying exactly the same product. All right. One important point with oligopolies is that we have basically 2 cases. So we have 2 firms on the market, and they are going to choose either the price they're going to set on that market or the quantity they're going to set. Remember, when we talk about a monopolist, we say the monopoly is facing a decreasing inverse demand curve, is facing the market demand, and it can either choose what quantity to produce and then deduce the price, the market price, or you can set the market price and then deduce the quantity that's going to be produced. Okay, so there is this one-to-one relationship between price and quantity when we talk about monopolies. With oligopolies, it's going to be different. So we are considering two cases. In the first set of models, we are going to consider firms that are going to choose the quantity they're going to produce. Okay, so you have two firms on the market. Each firm is going to set its individual quantities, and then you're going to determine the market price based on the aggregate quantity set by those two firms. Okay. An alternative to this, a second case, is where these two firms compete in price. So instead of setting quantity, firms are going to set price. So the firm is going to say, okay, I'm going to sell that good for $3, and the other firm on his side is going to set another price. Okay, so two cases, either firms compete in quantity, either they compete in price. In both cases, the way we're going to deal with this kind of models rely on game theory. Okay, so every equilibrium that we're going to investigate here will be a Nash equilibrium. Okay, so remember, what is a Nash equilibrium? A Nash equilibrium is a situation in which each agent, so here we're talking about firm, each firms want to do the best given the choice of its opponent. Okay? All right. So how are we going to determine the price and the quantity that are going to prevail in equilibrium? So as I said, we are going to use the Nash equilibrium, but the result, the market outcome, will depend on several parameters of the problem. In particular, it's going to depend on the variable on which firms compete. So whether they compete in price or in quantity, we'll get a very different results. Okay, so that's the first parameter. The second parameter that's going to play a role is the timing of the moves. Okay, so we're going to start with a scenario in which firms are going to decide simultaneously of the quantity or the price they want to set. Okay, so they're going to decide at the same time. And then we're going to move to a case in which one firm is going to set the quantity, and then a second firm move after and observe the choice made by the first firm, and then it's going to set its quantity. Okay, so we'll cover both the case in which the decision is made simultaneously by the firm and the case in which one firm decides before the other. The last parameter that's going to change here is whether firms are going to meet on the market either a finite or an infinite number of times. Okay, the result, the market outcome will be very different if firm meets once or if firm meets several times on the market. Okay. So as I said, there are many models of imperfect competition. In this problem set, we're going to start by studying the Coulomb model. Okay, so in the Coulomb model, firms are going to compete in quantity. So each firm is going to set its optimal quantity, anticipating what the other firm is choosing. Okay, so given that I expect that my opponent is choosing quantity QB, I'm going to set quantity QA. Okay, so in chrono competition, the decisions will be simultaneous. Okay, both firms are going to decide at the same time. Okay, so that's the first model we are going to cover. Then we'll move to the Stackelberg model. So in the Stackelberg model, firms compete in quantity, like in the Coulomb model, but one firm is going to set the quantity first, and the second firm is going to react to that, okay? The third model will be the Bertrand model. So with the Bertrand model, firms compete in price and not in quantity, and they're going to decide simultaneously. Okay, so both firms are going to decide at the same time what will be the price of their product. The fourth model we are going to cover is a Bertrand model with tacit collusion. Okay, so here, basically what we're going to do, we are going to assume that the Bertrand setting is going to repeat an indefinite number of times, and we will see that the Nash equilibrium that is going to emerge will be a collusive equilibrium. Okay. So I have reported here the relevant sections of the book, so 12.1, 12.2. I also mentioned the paragraph that you can skip. I really encourage you to read those sections. It's not super long, so I believe that you can take the time to read them. And it's going to help you understand better what we're going to do today, okay? I'm just going to give you a little bit of background, but I can lecture, so I'm going to go really fast. Okay, so the first problem. So the first problem is on the Coulomb and Stackelberg's oligopolies. So what happened here? So we have a stream. A stream is discovered whose water has remarkable healing powers. Okay, so you decide to bottle the liquid and sell it. So we have the market demand curve. And we are given the marginal cost to produce this new drink. Okay, it's $3 per drink, per bottle. So the first two questions are relatively easy. The idea here is to set a benchmark. So the first question is, what will be the level of output, QPC, and price PPC in the long run if this industry were perfectly competitive? Okay, so here we want to know what would be the equilibrium, assuming that this is a market of perfect competition. Okay, and then calculate the profit. So how do we do that? Okay, so for question one, as usual, when you are in a situation of perfect competition, you are going to set price equals marginal cost. Okay, that is going to give you your equilibrium. Okay, so price equals marginal cost implies 30 minus Q equals, sorry, I skipped a step. Okay, so price equals marginal cost means price is going to be equal to 3. Okay, $3. And what will be, so that's price under perfect competition. And what will be the equilibrium quantity in that market? Well, you just plug the price in the market demand curve, okay? So you end up with 3 equals to 30 minus Q. And so QPC is going to be 27. Okay. Right. So what are the profits? Well, we are under perfect competition. So you know that price equals marginal cost, which means that the profit is going to be 0. So the profit here is going to be 0. Okay. So here we have our benchmark. So now let's move to question 2. So question 2 is, what is the profit maximizing level of output QM and price PM if the market is served by a monopolist? Okay, so we know how to solve this question. Assume the market is served by the monopolist. Well, it's gonna set optimal quantity such that marginal revenue equals marginal cost. Okay, so we have the demand curve. From the demand curve, we can deduce the marginal revenue. Okay, so marginal revenue, remember, you keep the same intercept and you double the slope. And this is going to be equal to marginal cost, which is 3. Okay, so you have 2Q equals 27, or QM equals 27 over 2. Okay, so that's the equilibrium quantity for monopolists. What is the equilibrium price? So the equilibrium price is 30 minus QM, which is, so this is equal to 13.5. So the price is 16.5. Okay, so nothing difficult so far. Calculate the profit. So what is the profit for the monopolist? So pi m is equal to price minus marginal cost times QM. So price is 16.5 minus marginal cost 3 times 27 over 2. So if you calculate this, you end up with 182.25. All right, so I'm just going to highlight this. So that's the price, that's the optimal quantity, and that's the profit. Okay. All right. So now let's move to question 3. Assume that the market is served by 2 firms, firm A and firm B. What would be the market outcome if both firms form a cartel? Okay, so in this question, we are going to assume that firm A and firm B are going to talk to each other, and they're going to try to coordinate to increase their profits. Okay, so now you have 2 firms on the market. What is the market situation in which you get the highest possible profit? Well, that's the monopolist situation, okay? But now that you have 2 firms on the market, the only way for them to reach the highest possible profit is to coordinate somehow on the monopolist situation, okay? So what the firms are going to do, assuming that they are able to form and to sustain a cartel, they're going to produce at the monopolist level, and they're going to charge the monopolist price, and they are going to split the profit equally between them. Okay, so why are they splitting the profit equally here? Because we're going to assume that they have the same marginal cost. Okay, so if both firms incur the same cost of producing a certain quantity, then the cartel solution implies that they are going to split the production equally between them. Okay, so to find the equilibrium for the cartel, well, you want the monopolist quantity to be the sum of the quantity produced by firm A and the quantity produced by firm B. Okay, so this implies that little QA will be equals to little Q sub B, and that's going to be 27 over 2 divided by 2. Okay? So each firm is going to produce 6.75 units. Okay? So because the total market quantity produced by the cartel is the same as the monopolist quantity, then the price is going to be the same. So the price, I'm going to put cartel here. The price in the cartel case will be the same as the monopolist price. Okay, so that's going to be 16.5. Okay. So what are the profits? So the profit to firm A will be the same as the profit to firm B. Okay. And because they are simply splitting production, then they're going to get half of the monopolist profit. Okay, so that's going to be 182.25 divided by 2. Okay, so that's 91.125. Okay. So do you have question on this? Okay, so here we assume that the firm are able to commit to produce a quantity of 6.75 each. Okay, and that's the only way they can reach the highest possible profit, given that there are 2 firms on the market. So now the question is, will this market outcome occur? So in general, cartels are not observed in the real world for at least 2 reasons. So the first reason is that cartels are illegal. Okay. Why are they illegal? Because cartels are an artificial way to restrict the quantity produced on the market, to restrict the quantity available on the market. And so this pushes the price at a high level. Okay. And the antitrust authorities don't want that. Okay, so cartels are illegal. The second reason why we don't observe cartels in the real world is that they are not stable. The cartel equilibrium is not stable. Okay. In other words, although this is a situation in which both firms can get the highest possible profit, this situation will never occur. Why? Because each firm has an incentive to cheat. Each firm has an incentive to deviate from this production QA. All right. So cartels are not stable because each firm has an incentive to increase its production and gets higher profit. Okay, so someone mentioned, what about the OPEP, I guess. Okay, so I don't know if you have watched the news recently, but I believe it was 2 weeks ago, the price of gasoline was super low. Okay, and actually, yeah, and so the market for gasoline is one of the markets where you can find a cartel. Why? Because antitrust laws are laws in the United States, and they also exist in Europe, but they don't exist in the rest of the world. So different countries can coordinate to set their production level not too high, and this drives the price of gasoline up. Okay, so they can coordinate to restrict production and to end up with high profit. And as your classmate mentioned here, they tried to coordinate. 2 weeks ago, they tried to coordinate because the price of gasoline was going down like crazy. It became negative at some point. Why? Because Russia cheated on their agreement. Okay, they decided to restrict production because they saw that the price of gasoline was going down. They said, well, let's produce less and this is going to reverse the curve. And well, everyone said, okay, let's do that. But then Russia didn't respect this agreement. Okay, so that's an example that shows that cartels are not stable most of the time. Okay. All right, but we're gonna see in the last problem that some kind of collusion between firms can emerge when firms meet several times on the market. Okay, so some kind of, not cartel, but what we call collusion, tacit collusion, can happen on some market, in some markets. Okay, so do you have question on this? All right. Okay. So the cartel solution, so each firm will get a profit of 91. All right. So now let's move to question 4. So the market is now served by a duopolist consisting of firm A and firm B. And here we are not going to assume that they've made an agreement, okay? So both firms are going to determine their optimal quantity based on the beliefs they have of the quantity produced by the other firm. Okay, so how do we determine what we call the Coulomb-Nash equilibrium? Okay, so in other words, the equilibrium, the cartel equilibrium here is unstable. So this is not a Nash equilibrium. Okay, this is not a Nash equilibrium. And what we're looking for now is what would be a stable market outcome. And this stable market outcome will be a Nash equilibrium. Okay, so let's move to this. All right. So what is the process of decision for a firm belonging to a duopoly? So if you think about monopolies, okay, for monopolies, you have the demand curve, the marginal revenue curve, and the marginal cost curve like this, okay? And the monopolies set the optimal quantity where marginal revenue equals marginal cost, okay? So now we have two firms on the market. So let's say that I am firm A. How I'm going to determine the quantity I'm going to produce depending on the quantity chosen by firm B. Okay, so let's draw the market demand here. And I'm gonna say that this market demand is the market demand that firm A faces when firm B produces 0. Okay, so when firm B doesn't produce anything, then what I'm facing as firm A is simply the total market demand. Okay, now let's say that firm B is producing some quantity QB. Then what am I facing? Well, if firm B is producing some quantity, some positive quantity QB, I'm going to change the color here. Then I'm going to face what we call a residual demand curve. Okay, so let's say that's the demand curve when firm B, let's say, produce like 25 units. Okay, so when firm B produces 25 units, then the demand curve that I'm facing is the original demand curve shift to the left by 25. Okay. And we call this demand curve the residual demand curve. So assume that I know that firm B is going to produce 25 units. What is my best response to that? Well, I'm going to draw the marginal cost curve. Okay. And I'm going to draw the marginal revenue curve here. Okay. So if firm B produces 25 units, I'm going to optimally react by producing where marginal revenue equals marginal cost. And so my best response to firm B producing 25 units will be producing a quantity QA of, let's say, 12 units. Okay, so that's the process followed by firm A. So firm A determined its optimal quantity given its belief about what will be the production from firm B. Okay, so here I have drawn the case in which firm B is producing 25 units, but you can draw all the cases. You can say, well, I believe that firm B is going to produce 50 units. So in that case, I'm going to shift the original demand curve by 50. And that's the new curve I'm going to face. Okay, so that's the new demand. Okay. When QB equals 50. Okay, so how do I determine optimal quantity in that case? Well, if I believe that firm B is going to produce 50, then again, I'm going to look at the intersection between marginal revenue and marginal cost, and I'm going to produce QA equals something less like 5. Okay, so using this graph, you can see that you can calculate all the best responses of firm A to the different quantity produced by firm B. Okay, so from that graph, you are able to draw what we call a best response curve or a reaction curve. And this curve says, let's put QA here on the vertical axis and QB on the horizontal axis. This reaction curve gives you the optimal quantity QA that firm A is going to produce for all the possible quantity QB. Okay, so that's what we call the best response. Of firm A to the quantity produced by firm B. Okay, so so for instance, if I look at my blue curve here, I said when QB produced 25 units, then the optimal response, so when QB produced 25 units, the optimal response for firm A was to produce 12 units. Okay. And when firm B produced 50 units, when the best response to that was for firm A to produce 5 units. Okay. So you can see how from this graph, we can derive the best response function. Okay. All right. So now that you understand what happens, we're gonna do the math. Okay, I'm gonna erase this. So how do we solve this kind of problem? Okay, so first, remember we have the market demand, and the market demand was 30 minus Q. Okay, so now you need to be aware that Q is the sum of QA plus QB. Okay, you have two firms on the market. So our market demand is 30 minus QA minus QB. Okay. So the equilibrium we are looking for here is the intersection between marginal cost and marginal revenue, accounting for the fact that firm B is producing QB. Okay, so here I'm gonna first solve the problem of firm A. So firm A is gonna set marginal revenue equals marginal cost. Okay, the thing is marginal revenue is gonna be a little bit different this time. So what is total revenue? So total revenue, first notice that it's going to depend on both the quantity QA and the quantity QB. Okay, and this is going to be P times QA. So that's total revenue for firm A, which is 30 minus QA minus QB times QA. Okay, so I'm going to develop this. So 30 QA minus QA squared minus QA QB. Okay. So what is marginal revenue? The marginal revenue is the derivative of total revenue with respect to QA. Okay, so you're going to take the derivative of this expression here with respect to QA. So you end up with 30 minus 2QA minus QB. And you set this equal to marginal cost, which is 3. Okay. So basically what you are looking for here is this intersection for any quantity QB. Okay, for any quantity QB. All right, so now I'm going to express QA as a function of QB. Okay, and this is going to give me the best response. So QA, sorry, I have 2QA equals 27 minus QB, or QA equals 27 minus QB over 2. Okay. So this is the best response of A to B. Okay. All right. So what's the next step here? Well, now that firm A knows how to best respond to any quantity set by firm B, well, I want to find what will be the best response of firm B to any quantity set by firm A. Okay, so I want to solve the symmetric problem here. So what will firm A do? B do, okay? So firm B is going to do exactly the same. It's going to set marginal revenue of firm B equals marginal cost. So here there is a shortcut. Because when both firms have the same marginal cost, you know that both firms are going to have the same best response. You just need to substitute QA with QB and QB with QA. Okay, so I know that the best response of firm B to any quantity set by QA is going to be QB equals 27 minus QA divided by 2. Okay, so you just look at the best response of QA and you replace A by B and B by A. All right. Okay, so so I'm going to draw the best response right now to see what our equilibrium will be. Okay, so I'm going to put QA, QB. All right, so if you look at this, when QB is 0, QA is 13.5. So when QB is 0, QA is 13.5. Okay. And when QA is equal to 0 here, then you find that QB is 27. Okay. Okay, so that's okay, so that's the best response of firm A. Okay. So now I can draw the best response to firm B. And because the expression here is symmetric, then it's going to be easy. Okay, so I know that I'm going to cross the vertical axis here at 13.5, and here I'm going to cross the horizontal axis at 27. Okay. All right, so that's best response of firm B. Okay. So what is the Coulomb-Nash equilibrium here? Remember, when we covered game theory, we said that the Nash equilibrium was the intersection of the best responses. Okay, so the Nash equilibrium here is going to be where BRA and BRB intersect. So that's Nash. We call it the Coulomb-Nash equilibrium. Okay, that's the Coulomb-Nash equilibrium. So now that we know how to find the Coulomb-Nash equilibrium, let's find optimal quantity QA and QB. All right. Okay, so Nash equilibrium. So basically, we want to solve a system of two equations here. Okay, so let's start with this equation, and I'm going to plug the value QB in that equation. Okay. All right, so QA is equal to 27 over 2 minus 1/2 QB. And what is QB? So QB is here. So QB is 27 minus QA over 2. Okay. So QA is 27 over 2 minus 27 over 4 plus QA over 4. Okay. So this implies so you put the QA on the left-hand side. So you have 3/4 of QA equals 27 over 2 minus 27 over 4. Okay. And if you compute this, you find the Coulomb quantity for firm A. And this is...
Sorry, Professor.
Yes.
How did you get 27 over 2 minus 1/2?
Okay, so your question is about that?
Yes.
Okay, so this is, wait. So this is QB. Okay. Let me rewrite that. So if you look at QA, QA can be rewritten as 27/2 minus 1/2 QB. Okay?
Okay, got it. Thank you.
Okay, great. All right, so optimal quantity QA in the Coulomb equilibrium is 9. Okay. Now we just need to get the optimal quantity QB. So you simply plug QA in the best response function of firm B. Okay, so QB in Coulomb is 27/2 minus 1/2 times 9. And it gives you a quantity of 9. Okay. Okay, so exactly, because it's symmetric. Okay, so once you get the quantity for one firm, you don't need to calculate the quantity for the other firm. Okay, it's gonna be the same. It's gonna be the same as long as they have both the same marginal cost. Okay. All right. So we have our Coulomb Nash equilibrium. So now what is the market price? The market price in Coulomb is 30 minus QAC minus QBC. So that's 12. Okay. The last thing we want to do is to calculate the profit. So the profit to any firm, okay, it's going to be the same for firm A and firm B. So that's price minus marginal cost. So that's 12 minus 3 times optimal quantity 9. So P, C, A, or B is 81. Okay. Yes. So the question from Anisha, will we have to draw this graph for the exam? Yes, I can ask you that. Okay. All right. So let's look at the question. I believe we answered everything. Optimal quantity, price, best response functions, and profit. Okay. Do you have question on this? All right. So we can move on. Next question. Okay, so now we still have our two firms on the market and they are still competing in quantity. But now we assume that firm A is what we call the leader of Stackelberg. Basically, firm A is going to set its quantity first, and then firm B is going to observe the quantity set by firm A and react. Okay? So basically what we have here is a sequential game. Okay? So that's a sequential game in which the first player is firm A. So firm A is going to set, firm A has a choice between different quantity QA, okay? And then firm B is going to observe the quantity QA and is going to respond to that. So how do we solve this kind of problem? Okay, so when we have a sequential game, remember what we are looking for is the subgame perfect equilibrium. Okay, so the question is, how do we solve this kind of game? Well, we're going to use backward induction. It's going to look a little bit different from what we've done before, but basically that's backward induction. So what is backward induction? Remember, you start by the last stage of the game. So you're going to start solving for that stage. Okay, so what do we know at that? What do we know in stage 2? So we know in stage 2 that firm B is going to set QB following her best response. Okay, and we know that best response. Okay, so we know that if firm A set a quantity QA in the first stage, then firm B is going to set a quantity QB given by this equation. Okay, so now let's move to the first stage. What is the optimal behavior for firm A? Well, firm A is going to set a quantity QA in the first stage, knowing that firm B is going to react along the best response. Okay, so in other words, so what is changing here? What is changing is that firm A is going to take into account this information about the behavior from firm B when it calculates its marginal revenue. Okay, so let me show you that. So let's start with firm A. Okay, so firm B, basically we have solved the behavior for firm B already. Okay, so we know that firm B is gonna behave like that. Okay, so now let's move to firm A. Let's move to the first stage of the game. So firm A, so total revenue depends on QA and QB. And that's gonna be 30 minus QA minus QB times QA, okay? But firm A, no QB, okay? It knows that QB is 27 minus QA divided by 2, okay? So marginal revenue is gonna be 30 minus QA minus this times QA, okay? So I'm going to develop this. So this is 30 QA minus QA to the power 2 minus 27 over 2 QA plus QA squared over 2. Okay. So now let's calculate the marginal revenue from A. So that's 30 minus 2QA minus 27 over 2 plus QA. Okay. So if you compute this, you end up with minus QA plus 16.5. Okay. Marginal revenue equals marginal costs, imply minus QA plus 16.5 equals 3. And so QA for the Stackelberg leader is going to be 13.5. Okay. All right, so we have the quantity produced by the leader. Now, how do we determine the quantity produced by the follower, by firm B? Well, we already know that. We know that firm B is going to react to the quantity set by firm A, like this, minus QSA divided by 2. So that's 27 minus 13.5 divided by 2, which gives QSB equals 6.75. Okay. So what is the total market quantity? Total market quantity in the Stackelberg equilibrium is going to be the sum of QAS and QBS. Okay, so that's going to be 20.25. What is the market price? You just substitute 20.25 in the market demand, and so you get 9.75. Okay. So you can, looking at the quantity, what can you tell about the profit here? Are the firm getting both the same profit as in the corner case? Yes, no? Well, if you look at the quantity, you can see that firm A is producing twice as much as firm B here, okay? And these firms have the same costs. So from this observation, you can conclude that the profit for the leader of the Stackelberg, so the profit to firm A, the profit to firm A is going to be bigger than the profit to firm B, okay? In other words, when you have a scenario in which one of the firm can move first, then this firm is going to get a higher profit than the firm that moves in second. Okay? All right, so that's the Stackelberg equilibrium. So we say, just a point of terminology, that in that case, there is a first mover advantage. It's not always the case. Moving first doesn't give you always a first mover advantage. Sometimes firms who move first are going to get a lower profit than the firm moving second, okay? But when we talk about a corner setting, it will always be the case that the leader of Stackelberg is going to get a higher profit. All right. Okay, so the last question is compare all the market equilibria. Okay, so I'm just going to summarize what we have found here, and so I'm going to compare the price first. So the lowest possible price will be found in the perfect competition setting. Okay. Then you're going to get the price in the Stackelberg setting, the price in the corner setting, and the highest possible price will be the one set by a monopolist. Okay. Now let's compare quantity. So the quantity will be the highest under perfect competition. You can check with the number we found, okay? Then we have the quantity in the Stackelberg competition, then the quantity in the corner competition, and then the quantity when you have a monopolist, okay? Now let's compare the profit. So the profit are the lowest under perfect competition, okay? So we didn't calculate the profit in Stackelberg, but it should be profit in Coulomb, profit in Stackelberg, and Monopolist Profit. Okay. Okay, so that's just a comparison of the different value of price, quantity, and profit in the different scenarios. Okay. All right. Unless there's a question, I'm going to move to the next problem. Okay. All right. So, now we move to the Bertrand model. So in the Bertrand model, things are a little bit easier. So in that model, firms are going to compete in price and not in quantity. We will see that the market outcome will be very different from the one under Coulomb. And for the Bertrand model, we need to make a couple of assumptions. Okay, so basically, you're going to have two firms on that market, so firm A and firm B. And they're going to decide simultaneously on the price PA and PB they're going to set for the same product. Okay, so we need to make assumption on how the demand will be allocated between both firms in the different scenarios. Okay, so the first scenario is where both firms set the same price. Okay, so if both firms set the same price, then we are going to assume that the sales will be equally divided between firms. Okay, in other words, firm A is going to produce the same quantity as firm B, and that's going to be half of the total market quantity. Okay. Then what happens if firm A set a price below the price set by firm B? Well, in that case, demand goes to the lower price. Okay, because we're dealing with a good that's exactly the same, then the consumer are gonna buy from the firm that sell the cheapest for the cheapest. Okay, so in that case, QA is equal to the whole market demand. Last scenario, if firm A set a price above the one set by firm B, then QA gets no demand at all. Okay, so it's like demand is perfectly elastic between firms. Okay, so that's the assumption we need to solve that problem. So what is Nash equilibrium here? So you don't need to solve anything here to find the Nash equilibrium. You just need to think a little bit about what would be the best response for, say, firm A to any of the price set by firm B. Okay, so take the situation where firm A set the same price as firm B. Can this be a Nash equilibrium? Well, no. So PA equals PB. This is not a Nash equilibrium. Why? Because firm A would be better off charging a price PB minus epsilon, so charging just a little bit lower than the price charged by its opponent, and that way it gets all the market demand. So setting a price PA equals to the price PB is not a Nash equilibrium. Why? Because I have an incentive to undercut my opponent's price. Okay. Is setting a price PA above the marginal cost an equilibrium? Yes, so yeah. So Andre is anticipating, he said it goes to perfect competition. That's basically the idea, okay? So we just need to check that that setting a price PA above marginal cost is not an equilibrium either, okay? So if this is an equilibrium, well, it's not gonna be a Nash equilibrium, because if I set a price PA above marginal cost, then firm B is gonna set a price PA, PB equals PA minus epsilon and gets all the demand, okay? So the only equilibrium that is stable here is where PA equals PB equals marginal cost. Okay, so I should have said this. Okay, so what is the outcome of the Bertrand model? Well, it's both firms setting a price equals to marginal cost, and so the quantity produced by firm A is a quantity produced by firm B, and that's half of the market quantity. Okay, so that's the Bertrand equilibrium. Okay. Yeah, so here I didn't put, you're right, Anisha, I didn't put this assumption, but let's add it here. I would say firms meet once in the market. Okay. So you would get the same result in a finite horizon. Okay. So imagine a game in which firms repeatedly meet each other on the market, and you know that you're going to play the game 10 times. Okay. So the question is the Nash equilibrium of the single shot game also the Nash equilibrium of the finite horizon game? Okay, and the answer is yes. Why? When you play the game over a finite number of periods, to solve this kind of game, you start with the last period, okay, and you use backward induction. So what is the optimal behavior in the last period? Well, in the last period, you're going to behave as is you're facing a single stage game. Okay, so in the last period, the equilibrium will be to set price equals marginal cost. Now you can go one period back. Let's say you're in period 9 and not in period 10. You know that in period 10, you're going to behave by setting price equals to marginal cost. Okay, so what is the optimal behavior in period 10 minus 1? Well, it's also to set price equals marginal cost and so on. Okay, so the Nash equilibrium of the repeated game when the horizon is finite is the Nash equilibrium of the single shot game. Okay, but things are going to change if we assume that the game doesn't have an end. Okay, so first let's solve the first question of that problem here. Okay, so here we have a Bertrand setting, we have the market demand, we have the regular hypothesis of the Bertrand game, and the marginal cost is constant for both firms and it's equal to 20. So the first question is, if the firm meets on the market once, what is QIB? So the individual quantity produced by any firm I, the market price, and the profit. Okay, so we have just solved that. We know that if the firm meets once in the market, then the price of the Bertrand game is going to be equal to the marginal cost. So that's going to be 20. Okay. So what is a quantity produced? Well, you plug 20 in the market demand. So you end up with 100 minus 0.5 times 20. Okay. So total market demand is 60. And because you have made this assumption that production is split between both firms, we know that the production of firm A is the same as firm B, and that's half of the market demand. Okay. What about the profit? So the profit will be the same for firm A and B. Okay, and because you charge price equals marginal cost, the profit are 0. All right. Okay. The second question say both firms agree to form a cartel, and when you form a cartel, you have only one objective. It's to produce at the monopolist level. Okay, so they're going to set the price at the monopoly level, and they are going to coordinate on that monopoly price. So question, what is the market outcome here? So what is the equilibrium for monopolies? So you set MR equals MC. That's 100 minus 1/2, minus Q equals 20. So the quantity produced by the monopolist is 70, and the price charge, okay. Okay, I've made a mistake somewhere. Okay, so let's just change this. Okay, so that this is gonna be consistent with my notes. Okay. So this is not going to change. Okay. Okay, let's finish the monopolies first. Okay, so that's 50 minus Q equals 20. So QM is 30. And the monopolist price is 35. Okay.
Professor?
Yes.
Sorry, since you changed the market demand to 50,
yes.
So can you just like specify like the calculation on how you got the profit? I mean the price.
Okay. So price is 50 minus 1/2 of 30. Okay. So that's 50 minus 15, which is 35. Is it clear?
Thank you.
Okay. So we would need to double check this, but we are ultimately interested in the profit level, okay? So the profit, whatever the equation of the demand curve, the profit are gonna be 0 in that scenario here, okay? All right, so I'm running a little bit late. So let's move to, well, I want to calculate the profit first. So what is the monopolist profit? So it's PM minus MC times QM. So that's 35 minus 20 times 15. Okay, so that's the profit of an individual firm. Okay, so I'm gonna put I here. And that's 225. Okay, so if the firm are able to coordinate on the monopoly price, so they both charge the monopoly price, then they would each get a profit of 225. Okay. All right. So question 3. Assume one firm defects from the agreement and set its price slightly below the monopolist price. What is the profit from deviation? Okay, so here we have assumed the coordinate on the monopolist equilibrium, but as we know, this is not a stable equilibrium, okay, because this is not a Nash equilibrium. Okay, so one firm will have an incentive to deviate from that equilibrium. And how does it so? Well, by setting a price slightly below the price of the monopolist. Okay. All right. So by doing so, what is the profit from deviation? So the profit from deviation for the firm that deviates. Well, the firm set the price just a little bit 35, let's say 34.99. Okay, so for simplicity, we'll assume that it's close to 35. And it gets all the demand, right? Because now it is charging the lowest price. So the profit is price, that's going to be 35, a little bit less, times minus marginal cost, which is 20, times total market demand. Now it gets all the market demand. So what is all the market demand here? So when the price is 35, that's a monopolist demand, okay? So total market demand here is 30. Okay, so the profit from deviation here is going to be 450. Okay. And by actually calculating this profit from deviation, you show that a firm has an incentive to deviate. Okay, by deviating from the agreement, it moves from a profit of 225 to 450. Okay. All right. So that's a profit from deviation. Okay, so I know I'm running late. So you can, so I'm going to continue and finish this. Of course, you can leave if you have other things to do and catch up later by watching the video, but I'm going to continue if that's fine with you. Okay? Is that okay? I believe you can use...
So, Professor?
Yes.
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 Yes, okay, good. All right.
Next week's the exam, right?
Yes.
Okay, just making sure.
Okay. All right, so we have the profit from deviation. Okay, so now let's move to question 4. That's our last question. Represent the Bertrand game in a matrix. with price being the actions and profit being the outcome. Okay, so here we have calculated the profit when both firms behave as in Bertrand. We have calculated the profit they get if they coordinate on the monopolist equilibrium, and we have calculated the profit from deviation. Okay, so with all this information, we will be able to represent the matrix of the game. Okay, so let's say this is from A, from B, or whatever. So each firm has two strategies. Either it can deviate from the monopolist equilibrium, so let's say defects, and set a price below the monopolist price, okay? Or each firm can collude and keep its price at the monopolist level, okay? So in that case, P equals 35. Okay, so that's the same here. All right. So if both firms collude, what profit do they get? Well, we have calculated here the profit under collusion. So they behave as like the monopolist and they split the profit and they get 225. Okay, so if both firms collude, they both get 225 here. If both firms defect, which means they are playing the Bertrand game, then they both get a profit equals to 0. Okay, so that's the Bertrand outcome. Now let's say firm B defect and firm A stick to the collusion. In that case, we calculated the profit from deviating, and that was 450. Okay. So the firm with defects gets 450, and the other one gets no demand at all. So it gets a profit of 0. And that's the opposite here. So if the game is played once, what is the Nash equilibrium? Okay, so here you can easily see that the best equilibrium for both firms would be to collude. Okay, they would each get 225. But the Nash equilibrium will be the equilibrium in which both firm is going to undercut the price set by the other firm. Okay, so the Nash equilibrium here is going to be both firm defects. Okay, so that's question A. Now let's move to question B. Now you assume that the game, so that game is repeated an indefinite number of periods. In each period, firms set their price simultaneously and follow a trigger strategy defined as follows. Okay, so what is a trigger strategy? The trigger strategy says, I'm gonna set a price equal to the monopolist price, so I'm going to stick to the agreement in initial period, and both firms are going to do so. Okay, so initially they are on the monopolist equilibrium. Then I'm going to set the monopoly price as long as the other firm has set the monopoly price in all previous periods. Okay. And then I'm going to set the Bertrand price. So what is the Bertrand price? Its price equals marginal cost. If the other firm has ever set a price other than the monopoly price. Okay, so if my opponent has cheated at least once in the past, then I'm going to punish her by setting price equals marginal cost. Okay, and that way I get all the demand and she gets 0 profit. Okay, so this combination of strategy is called a trigger strategy. Basically, I'm nice as long as you behave nicely, and if you don't behave well, then I punish you by setting price equals to marginal cost. Okay. So if both firms play this strategy, what are the conditions to support a collusive Nash equilibrium? Okay, so what we're going to show here is that firms are actually going to collude when the game is repeated an indefinite number of periods. Okay, so first we are going to compute the profit, the intertemporal profit from collusion if the firms stick to setting the monopoly price forever. Okay, so what is the profit from collusion for any given firm? Well, in the current period, I get a profit of 225. I collude, I behave well, I get 225. What do I get in the next period? Well, if I behave well, I know that the other firm is going to behave well and set also the monopoly price. So I'm gonna get also 225. However, I value the next period less than the current period, okay? So I'm going to discount, I believe in your book it's called G. I'm going to discount this amount by some value G that's going to be less or equal to 1. Okay? Then what happened in the third period? Well, in the third period, if everyone behaves well, I'm going to get 225. But because it's 2 periods further, I'm going to discount even more the payoff I get at that period. Okay, and so on. Okay, so there is no end in that game. Okay. So how do I compute the intertemporal profit here? So I'm going to ask you just to learn about that. This is a geometric sum, which is equal to 225 over 1 minus G. Okay? So that's the profit I get if I collude for the rest of the time. Now, what is the intertemporal profit I get if I defect in the next period? So in the if I defect, then I'm going to get a profit of 450. Okay, I'll set a price below my opponent price and I get all the demand. Okay, so I get the monopolist profit. But then, because I cheated, I know that my opponent is going to punish me and it is going to set price equals marginal cost forever after. Okay, in other words, we're going to both get 0 profit for the rest of the time. Okay? So knowing that, what are the conditions that would support collusion here? Well, we will observe collusion if and only if the profit from collusion is higher than the profit from defecting. Okay? And now I just need to solve an inequality. So I'm going to replace the profit from collusion by 225 over 1 minus G. This must be higher than 450. Okay. So that's 1 minus G higher than 225 over 450. So this is G, I'm sorry. This is G smaller than 1 minus 225 over 450. Okay, I have a sign issue here.
Professor, I might
Yes.
have to leave my other class out in 5 minutes.
Sure, sure. Just check the video when
All
it
right,
is
thank you
online.
so much.
Okay. Of course, if you have other things to do, you can leave. I just want to finish this, or I will have to schedule another session, which I don't want to do. Okay.
All right, thank you.
All right. Okay, yeah. So the sign here, sorry, that's the opposite. So, so this is smaller, and so G is higher than this, and this is 1/2. Okay. So, what does it mean? So G has two interpretations here. G is the probability that the game is going to be repeated in the next period of repeating the game. So with this interpretation, it means that if the probability that the game is going to repeat in the next period is high enough, then firms are going to collude on setting a price at the monopolist level. Okay. Another interpretation of G is the patience of firms. So if firms are patient enough, it means that they wait the payoffs that they're going to get in the future. And because they wait this payoff, it gives them an incentive to participate to the collusive outcome in the present. Okay, so if this G is higher than 1/2, then the Nash equilibrium of the repeated game will be that both firms are going to collude forever after. Okay, so ultimately, the outcome of the game is going to depend on this value of G here. Okay. So just to finish on this, so if we observe this, we have a collusive outcome, and this collusion is tacit. Okay, so there is no objective agreement between firms to sustain price equal to monopoly price. Okay, so it's simply, this equilibrium simply emerge because firms are patient enough. And this equilibrium is also self-enforcing, which means that we don't an external authorities to force firms to set price equal monopoly price here. Okay, the incentive to keep a price at the monopolist level is motivated by the threat of being punished by the other firm setting price equals marginal cost, and both firms getting zero profit for the rest of the time. Okay. All right. So I'm done here. I really recommend that you read the book section about this. It's very clear. It's not very long. And that's section 12.4 here. Okay. So do you have question on this? I have one question here. Yes, the lecture will be posted on Blackboard as soon as it is available. Okay. Do you have other question?
Hi, Professor. I have a question about the midterm for next class.
Say again?
I have a question for the midterm for next class.
Yes.
I was wondering, are we going to have the questions where we have to take a picture, like do the work on a piece of paper, take a picture, and upload it again? Or
yeah,
will,
maybe.
Okay, maybe.
Yeah, that's a possibility.
Okay.
So honestly, I haven't prepared your exam yet, and I think I will be clearer on this when it's ready. I plan to do it in the next days, and as soon as it is ready, I'm going to send you an email explaining exactly what will be expected. okay, whether you will be expected to scan something or whether everything can be filled in online. I don't know yet, but that's a possibility.
Okay, thank you.
So make it easy, yeah. I'm gonna try. Other question? All right. So take care, everyone, and I'm going to follow up with emails very soon. Okay. Take care. Bye bye.